Hi everyone and welcome to Back to Spec 83. This is episode 2 and apologies for this video going up a few days later than originally planned. But I've been busy. You may have seen the community post that I put out just a couple of days ago in that I've been working on a new ZX Spectrum basic game. It's called Quadrangle, nice and simple. But the reason why I've done this game, I've created this game, is simply to show you guys obviously the simple commands that can be used to create your very own games. So it's got controls, collision detection, it's got timers, it's got high score keeping, it will store the high score throughout the games. It's got a few little other fun little perks to it. It isn't the greatest game of all time, written in BASIC, granted, but it is just a game to show you guys just what some of the commands are freely accessible when you create your own games and what those commands can do. It has been programmed on an emulator on my laptop throughout the week as I've been sat downstairs. So we're now going to have to take it from the laptop and put it onto the Spectrum. We can't do it with a simple save onto a USB card, and we can't plug that USB card into the Spectrum and the game will run. It doesn't work that way. For some reason, and I think it's something to do with the dynamics of the PC or the laptops that you use, and obviously when you save games written in ZX Spectrum language, basic language, something changes behind the scenes. Now, I'm not technical, I'm not savvy in that way, so I don't really know why this is an issue. But the Spectrum will not load games that have been programmed on an emulator. Perhaps you guys can explain why in the comments down below. So what I'm going to do, I'm going to take the game from the laptop, I'm going to read through it as we type it, as we input it into the ZX Spectrum. And along the way, I will discuss what some of the lines do, what some of the commands do. Now, if you want to bypass all of that and just get straight to the gameplay, by all means do so. Now, as for the game being readily available, I haven't quite yet set up an itch account. I am going to be doing that, where all these little programs that we create will be added and uploaded. So you guys can download them for free, you can tweak them, you can do what you want with them. All I'll say is please don't sell them as your own. Don't make any profit from them. I don't make profit, you guys please don't make profit from them. That's that over with. Let's get into the program itself. And like I said, if you want to zoom past it, if you want to zip past it and get to the game itself, by all means do so. But you may learn something along the way if you do watch the actual following and the actual programming of said game. So without further ado, let's get into it. So we're into Retro Games' ZX Spectrum as we discussed in episode 1. And the reasons why we use this computer, this ZX Spectrum, is because the two behind me are quite, well, they're old and the signal quality isn't brilliant. Please check video 1 for more reasons as to why obviously I'm not using those two models which are just sat behind me. So we're going to get into the program itself and we're going to start with line 10. And it's a simple 10 go sub 720. We'll get into what these routines are shortly. 20 go sub 660. 30, we're going to clear the screen. We're going to set up the paper, the background, the ink, and other attributes for, obviously, the variables for this game. So we've got paper. It's paper 0. Let high equal 0. Let shield equal 0. Enter. Now we can just continue putting more variables onto line 30, but for the sake of this video today, we're going to continue with how we've scripted it on the actual emulator itself. So line 40, let's continue. So we've got let x equal 10. Let y equal 5. Let SC equals 0. Let SX equal 0. Let SY equal 0. Let DS equal 0. So line 40, you will notice that there's quite a few zeros in the variables, some of which we may be using and we may not. It's one of those. So like SX and SY variable, that isn't used at the moment, but I do have a plan for that, for a nasty that we may include into this game at a later date. But X and Y, self-explanatory. That is where you, the player, will begin each game, each level. SC is the score. You've got, obviously in line 30, you've got shield, which we'll come to shortly, and you've got HR, which stores the high score. So line 50, let D equal 4, and let DP equal 1, let OP equal 0. Now let D is which direction our white block is facing at any time. So it could be up, down, left, right, 1, 2, 3, 4. DP is drop pixel or drop prism or however you want to word it. But basically, if it's set to 1, that means there's an active box on the screen. If it goes to 0, there isn't, so the script will randomise where to place the next flashing red box. So 60. Let max frames equal 30 times 50. This is a timer script that that I have included into the game. It's not exactly 30 seconds, but it's close as 30 seconds you've got to complete each level. If the time runs out, the game ends. So you've got to keep collecting the red square to keep the time reset to 30. So if you get down to 5 seconds and you collect the red box, the timer will reset to 30. But it just gets more difficult because the longer you play each level, obviously the white boxes that you leave behind, the trail you leave behind, is filling the screen, and it gets more and more difficult. So the whole aim of the game, basically, is to see how many points you can accumulate at any one time. If you collect the red box also, I should add that you also gain an extra 100 points. Every move, up, down, left, right is 1 point. Every red box is 100 points. But the red box also resets the timer. Right, line 80. So we're going to go sub 320. We'll get to what these go subs do when we get to them. Line 90. I have put a REM statement here, but we don't really need it. Now, line 100 is self-explanatory. If frames equal 0, then stop. So basically what it's saying is, if the timer itself runs down to 0, then just stop the program. We haven't actually got an end of screen set up just yet for that situation. We have got one when you lose your life, you crash into your tail that you've left behind, or you hit the boundary walls. But at the moment, we haven't actually got one should the timer runs out, but we can put that in at a later date. Now, line 110, we need to basically set the timer up fully. So we're going to go with let T left equal INT frames divided by 50. Bit difficult to explain what all this does at the moment. All I know is it is setting the timer up, and I have had to use some resources, some magazines to dig this out. But the T left function is basically storing what time is left. And then we're on to line 150. Let PX equal INT RND times 20 plus 1. 160. Let PY. So PX and PY are where the random box will appear on the screen one at a time. Once you've collected it, it'll disappear and reappear somewhere else. That is your PX and PY routine. And as you can see from lines 150 and 160, they are the randomised locations of PX and PY. So let's continue. R&D times 30 plus 1. Print. Now, we are now printing the actual X and Y location of your character. And we're going to do that using ink 7, which is white. Sorry. Now, I know what you guys are thinking. Why are you setting up a graphic in that command? So what we'll do, we will go to where obviously those graphics are, the user defined graphics, and character A is a black block. So we'll get to that now. We'll poke the user defined graphics in, and then it just makes more sense as we go along with this program. So that is lines 660 up to 710 inputted into the game. What them 3 lines will do, obviously, will create the 3 sets of graphics that we're going to be using in the quadrangle game itself. So you've got the user control one, you've got the red flashing block, and you've also got the shield, the power up, if you will. Now, if we run lines 660 onwards, we have got a return without go sub, which is fine because obviously the computer is trying to go back to another go sub which isn't there. But if we press enter now, as you can see in line 170, you've got the black square. That is the user's player, if you will. That is what is going to be the white block that we control around the screen. But them are the 3 UDGs now set up. So we're going to continue with line 180 and we're going to set up the score. Now, every time we move our character, you will gain 1 point. Line 181. And this poke I've used on a few programs. Whether or not it works, I don't know. But basically, it's supposed to clear the last key pressed. In theory, it should help speed up the key command for your next move. Whether or not it does or doesn't, I think that's something I need to try and experiment with in future. But for now, we'll keep it in. So now we're going to put let $K equal, obviously, the in keys, because it's the in keys which is going to obviously control the player. Now you'll notice that I am actually typing in now. When you press QAOP, we're telling the variable D which number to be. So Q is 1 for up, 2 is down, 3 is left, 4 is right. And again, this is all to do with the programming of where your character is going to move on screen. So 188 is if $K equal O, then let D equal 3. And 189 if $K equal P, then let D equal 4. Nice and straightforward. So what we're doing now, we're setting up the D variables with the controller. So if D equal 4 and Y is less than 31, then let Y equal Y plus 1. So lines 230 to 260 control the up, down, left, right. And it makes sure that if you hit the top, bottom, left and right, or the four edges of the screen, again, depending on if you pick the shield up or not, you will die. The game will be over. So we're now going to continue and we're going to keep going ahead with this program. We're going to start with some attributes now. So line 270, if, and the ATTR command, basically it's going to look for a colour. So the ATTR command is going to check the X and Y position of your player. And if it equals 177, then let shield equal 1. Then we're going to print at naught, 13 ink 7 shield on. So basically, if you collect the shield, and it's an attribute, and attributes are a bit like screen $ collision detection commands that we use. And the ATTR is seeing where your character is on screen, and if it touches a colour which is related to number 177. We're going to get into where we get 177 from at a later date in a future video. But basically, that is the colour of the flashing red square. We'll touch upon, like I said, we'll touch upon what all this means later on in future programs, but for now I just really want to get this one up and running to show you guys and explain along the way what the commands do, but without getting into too much detail here and now. So that's what line 270 does. If you collide with the red box, it is saying that this shield is on. So 274, if T left equals 25 seconds, we're going to then let DS equal 1, and that is display shield. So DS equal 1 will display the shield once 25 seconds on the clock is hit or is being displayed. So then we print at, for now I've put it in location 5 and 5, X and Y 5. We're going to make this a random appearance again at a later date. I'm just trying to show you guys where I am with this program at the moment and with this game. So it's going to display it at 5.5, paper 6, and then we're going to flash 1. So this will kick in the flashing of that icon, and then it's graphic C. And as you can see, the graphic C is a square with another square in the middle of it. That is what we put as a user command in line 660 onwards. So line 280, if ATTR bracket X comma Y equals 7, then go sub 540. If we go back on our tail, so if we loop around controlling the character and our little white square hits itself, it is game over. It's collided with itself. So it goes to line 540, which is an end of screen or end of game, basically display screen. Self-explanatory. 290. If drop pixel or drop prism equal 1, then print at px, py, paper 2, ink 5, flash 1. And then it's A again. And then let dp equal 0. So what line 290 does, it actually displays the red flashing square. And what it's saying is it's going to turn the paper to red and it's going to ink 5 and flash 1. So you will see it flashing. Let dp, it's reset it to 0, because once it's displayed on screen, you don't want another one being displayed. It'll only display one red flashing box. So it starts with if dp equals 1, then blah, blah, blah. And then reset it to dp 0 for the loop of the game. So you'll only ever get one red flashing box. Now line 300, we're going to let frames equal frames minus 10. What that script does, it is now telling the countdown timer to begin counting down to 302. Print at 21, 0, ink 7. So we're now going to put the score in. So every time you move that block, you gain 1 point. And then print at 21, 10. And have you noticed, this is at the very bottom of the screen. And it also stores the high score next to it. Line 303, print at 21, 24. Time. Now this is the time. And we leave a space. And the reason why we leave a space is because every time the clock ticks down, what it does, it has to make sure it's hard to explain, but when it goes from 30, from 2 digits, from 30 set down to 9, it left a 0 behind the 9 to look like 90 seconds. So the space refreshes it. So once it goes from obviously 30 down to 10 and then 9, after the 10, the 0 disappears and it stays 9, 8, 7, 6. I think that makes sense. And that's exactly what that line does. And line 3 or 5, we print pretty much something similar. So print at 21,24 time and leave a space and then T left. So there's a space, then prints the time. And then 310, we go to line 90. So it's looping at this point. The game is now looping. Now, line 330, this is where, sorry, line 325 is where now we set up the actual screen itself. So we're going to have a black background with a blue grid. And 330, this is where the fun begins. So you have to bear with me at this point. So this is where now where we put all the grids. So as you can see, I've got 30 squares across the screen, and I need to do that several more times to get down to 20. So it's 30 by 20. I did try doing this with a plot and draw command, but the screen just takes too long to initialize. So doing it with a UDG, user defined graphic, it just speeds that process up. Now you may want to fast forward this bit as I type the rest of this in. The simplest way to do this is to go to line 330 and type in 40. But the problem is, you've got to still go across to change this to line 2. And then line 50. 3. So you can copy and paste basically. You're doing it this shortcut way. So it's Cap Shift and 1. It'll show the last line. Change that to 360. Work your way across. Line 4. Right, we'll carry on. Come back shortly in a short time. So, we finally got our grid set up. Now, if we run 330, I think it was, onwards, it should display the screen, but you'll have a go sub error again. So there is your screen. At the moment, it's still set up with a white background and black, obviously, grid. But all will be revealed once, obviously, the game begins. But that is the grid now set up. So now we continue 540. And then I'm going to put a rem game over command in. So, first of all, we're going to set up the shield. So if the shield equals 1, we're now going to, we're now going to basically tell the computer to turn the shield back off. I know that sounds a little bit weird, but the reason being, if the shield's 1, when it gets to the game over routine, it resets it to 0, so you can't cheat by keep going through your own tail. It's like a shortcut to, obviously, a longer programming process. But if shield is 1, then let shield equals 0, because it's looping to see if you have collided. And if you have done, and the shield's on 1, it'll let you go through the tail, but then reset it to 0. So if you try to go through the tail again, you will die. Unless, of course, you've picked up the shield flashing block. Hopefully that makes sense. So print at 0,13 ink 7 spell now, shield off. So basically what's happening is the script's going to see if you've actually used the shield. So if you've crossed over your white line, it'll tell you at the top of the screen that your shield is now off. So if you collide with your tail, you will die. Again, it sounds simple, But I understand why some people may get confused with that. But hopefully it will. Again, I keep saying it, don't I? But I hope it will make sense. Obviously, any questions, just comment down below. So line 550 is where the actual game is over. So we'll make this quite quick, I think, just so you can see the game working. 560 prints at 11,8. Again, I do like using this flash. And then it's game over. 570, let D equal 0.6. And 580. So what we're doing now, we're putting a few beep commands in. So 570 onwards is basically a beep command, a beep routine. It's going to play a little tune just to say that the game is over. Nice and simple. So the border is now white. We're going to beep D, 5, border, border not, beep D, 3, border 7. So it's going white, black, etc. Pause. 15. 590. Try that again. 590. Border naught. Beep. D, 3. Border 7. Beep. D, 5. Border naught. Beep. 1, -2. And then pause. We'll pause 10. And then we'll border 2. Beep. And then border 2 is obviously red. Or not. Again, you can change the beep command. You can have whatever tone you wish. And then print at 13,5. Press any key to play. And then obviously it's line 610. Let's $, equals inkies 620 if inkies equal, then go to 610. So it's waiting for a key press. 630 if inkies, then go to 630, is it? And then obviously 640 if SC is the same, is greater than high score. So if your score is greater than the high score, then let the high score equal SC. And then let SC equals 0. Resetting the score to 0 for when you go back into the game. And then we're going to do all the resetting of the screen colour, the border colour, and then we're going to go back to line 40, which takes you back into the game. We've done the UDGs, the user defined graphics. Now line 700, we can do a quick one, can't we? So let's put in line 720, CLS, paper, naught, border 2, ink 7. And what we're doing is setting up, try that again, line 720, delete line 72. Right, sometimes that happens. You forget to put in a 0 for your lines and it takes you back to the very beginning and it can cock a lot of things up. Anyway, let's get on with it. So line 730, print at 4, 10, quad quadrangle. So basically we can put in all our instructions, yada, yada, yada. Obviously it'll tell you what you do, what not to do. If you hit the block, obviously it resets the timer. If you move, it collects a point. If you hit the sides, you die, all that kind of stuff. So we'll skip all that for now, and I'm going to jump to line 820, print at 18,5, ink 6, flash 1, press any key to play. That, thankfully, is the program typed in. We've taken it from, obviously, our laptop and the emulator. We've retyped it into the ZX Spectrum. Now, let's see if it runs. If it runs first time with no issues, I will be amazed. Like I said, we can expand upon the actual intro screen. We can put the instructions, yada, 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 into it. But for now, I just wanted to get this up and running to show you guys exactly where we're at. So let's type in run, enter. So it didn't wait for a press any key command, but as you can see, the white boxes are moving. We've got a flashing red light. If we hit the shield on, as you can see at the top of the screen, shield has come on. So technically I can actually go through the white line. So let's go through, shield's off. Now if I crash into my white line, I will die. And as you notice, the timer bottom right, there we go. We're dead because the shield went off. And that is what the DS display shield command means. But you will notice that the timer was in blue. So let us go back into the program and let us find where that actual instruction is, because we want the timer to be in white like the others. So it's line 302. So it's going to line 303 onwards. So line 303. Let's try that again. So list 303. And then let's put ink 7. This is what I like about the programming side of the ZX Spectrum. If you make these little mistakes, it's not a big problem. You can go back into the program, you can change things, add things, remove things. It's not that difficult once you get to grips. I'm struggling a bit with the keyboard because I'm used to the emulator on my laptop. I will admit to that. But otherwise, once you get used to everything, it's great programming and creating your own games. So let's run it again, and hopefully the timer this time is fine. There you go. Now what you will notice, the actual blue grid itself isn't all the way to the right hand side of the screen, but we can change that. I can add an extra box, which I'll do shortly or in a minute. Shield is on. Now also we can add sound effects to this game. Now the question is, why didn't the other red box come on at that point? And again, this is another flaw sometimes with programming games. You have issues where you get glitches, and in that instance, the actual red box didn't come on. So let's try again. Right, you notice the red box itself isn't appearing once you go through, so we've obviously missed something. But again, this is the fun and the joys of programming. So let us go back through the code and see. Now I know what the issue is. Just before line 270 and where it says if ATTR bracket x, y equal 177, we're telling it just to print shield on. So you've picked the shield up. Before that, however, we also need to put in another command at 265. And it's another if ATTR bracket x, y equals 149. That is the colour of the actual red box itself. If we hit the red box, then we're telling the program to add, if I can find it, we are telling the program to add 100 points to the score. Pause my words then. So let's add 100 and then let DP equal 1. And then what we'll do, we'll also put a beep command in, beep, point, 01, comma, not 1. Let frames equal max frames. So basically what line 265 does is when we hit the red box, you get an extra 100 points. The box disappears and relocates elsewhere on the screen. It also resets the 30-second timer. So let's run the program again and see if that works. Don't worry about the press any key instruction. We can sort that out at another time. So if we go into the red box now, what should happen is it should appear somewhere else. There we go. And if you notice at the bottom right hand screen, the timer has now reset itself. So we've got 24 seconds to get to that next red box. And you can also hear the beep. Now, if you notice, the red box is now starting to be hidden between white lines. So if we get the shield, we can go through the shield, go through our tail, collect the red box, unless obviously you hit the tail again and then you're dead. But that's the premise of the game. Collect the red box, gain more points. Collect the shield, you can cut through your tail. And then you keep on going. But every game, you've got to try to better your last score. I went back on myself, then I pressed the wrong key. But if you notice at the bottom centre of the screen, the highest score is now set from the first time I played it. And the highest score is currently set at 338. So let us go down. So we've already hit the highest score again. And I've just missed it. Missed the red box. Bad timing. I have to say though, the keyboard is quite clunky with this because it is a basic game. So you have to remember that with it being basic, the game is slower than obviously if this was written in machine code. So the keystrokes are a little bit clunky. I will say that. Again, I went back on myself. But the whole point of this game and this episode is to show you guys just what you can do with it. Just a little bit of imagination. And if you want to dabble your hands or get your hands dirty with programming in Spectrum Basic, this is what you can do. Because this game has all the elements of a basic game. You've got, obviously, you've got movement, up, down, left, right. You've got plenty of collision detections going on. So my shield is now on, as an example. You've got a timer in the background. It'll store your high score. And it can be just a challenging little game. Didn't time that right at all. But this is it. This is the game. Now, what I'm going to do before the next episode, I will finish off this program. We'll put an intro screen. I think what we will do, we'll also add maybe a nasty to the game. But you have to remember, the more things that appear on this screen, the slower the game will get. That is the only problem with Basic. It will get slower the more we add to it. But, like I said, if you're interested in programming, then obviously keep on coming back to this channel. Because I do hope you find it interesting. I'm doing bloody well here. Right. Now I can actually go through my tail. So if I go through my tail... Oh, I can't. I didn't get the shield. What am I talking about? Not a bad run at it though anyway, was it? So my high score is 1073. That's the best I've actually ever had. I've been playing this game for pretty much all week on my emulator. I think what we'll do, we'll also randomise. We'll randomise where that shield appears. Shield off. I forgot I had it on. So we can randomise where that shield appears on the screen. I think that would be a good little thing to add. We can change the game. I mean, we could have it if the countdown hit 0. You survive the level maybe. Oh, I messed up there. You could actually survive the level and go to an even more tricky level. There's loads of potential we could do with this game. But like I said, I wanted to show you guys exactly what I've been working on. And just how you can create your own little game in Basic. Let's go and get the shield. Once I die in this game, we'll call this quits. So shield is now on. It's activated. So again, I can go through my tail. Oh, now I'm stuck. I've now blocked myself in completely. Game over. But if you've enjoyed this, and like I said, it might be a longer video than I would normally plan, please give us a big thumbs up. Please don't forget to subscribe to the channel. Also, tell me your little hints and little tips that I can learn from. You've probably seen something in that program itself which doesn't make any sense. Comment down below, I'll try and answer it. There might also be things in that program which you could do better to speed this program up. But like I said, it's a ZX basic program. So it's all about learning programming in basic language, trying to get that simple little game up on screen. But if you can do those things, thumbs up, subscribe, I would really appreciate it. Now, I'm going to carry on playing this. I'm going to add an intro screen. I'm going to expand that grid one step further across, one column across, because I didn't go enough. But yeah, I really do enjoy this type of content and actually programming in old basic language. So ta-da guys, I'm going to crack on, and hopefully I'll see you and all in episode 3. Right, what am I on? 1073, come on. Dead straight away.